So this is G485 homework booklet question 30, the last one. So the first question is explain what's meant by the critical density of the universe, and you could describe that as being the density of the universe that will result in a flat universe, or you could explain what the flat universe is, so the density for which the universe will tend towards a finite limit, and that's the limit of size, so will tend towards a finite limit. Part B asks you to imagine that cosmologists have determined that the Hubble constant is 65 kilometers per second per megaparsec. Calculate the Hubble constant in per second and hence determine the critical density of the universe. So 1 parsec, they tell us very handily, is 3.1 times 10 to the 16 meters. So there's the 65 that we were given, and they'll tend to give you a different figure each time just so you can't learn that answer in per second. There's a 65 kilometers per megaparsec. So to get that into meters per second per megaparsec, we'll need to multiply by 1,000 for the kilometer rather than meter. And then I don't want that per megaparsec, but per meter, which will get me down to meters per second per meter. In other words, just 2 per second. So I'll divide by the number of meters in a parsec, which we were given, but it's per megaparsec, so I need a 10 to the 6 as well. Do those sums, I end up at 2.1 times 10 to the minus 18 per second. I would always do that as a separate side calculation. It's always going to help you along the way, picking up C marks. And then row naught is a straightforward calculation, putting that into that standard sum again, do the substitution, and on this occasion we end up at 7.9 times 10 to the minus 27. And then we get to part C, which is to explain the terms open, closed and flat, and describing the possible evolution of the universe. On figure 30.1, sketch and label the graphs to illustrate your answer. It's interesting here, the mark scheme only gave ideas for what you might write here, and given that there are 3 marks and 3 slots, that's perhaps not surprising. It's not clear whether you could have also have got that from the graph. I think certainly closed, you'd hope that if you had something going up and going down, they'd have and labelled that closed, they'd have awarded the mark for closed, as long as it didn't contradict what was written. Open and flat are perhaps harder to distinguish in terms of what's going on. So open is a universe which will expand forever without limit. Closed, a universe which will stop expanding and then will contract. And then the one that's always difficult to describe is the flat universe. And the difference between the open and the flat is very, very subtle. In both cases, they're going to carry on expanding. They're going to carry on expanding, if you like, forever. And they're going to carry on expanding, but at a decreasing rate because gravity's slowing that down. The difference is essentially the form of the mathematical function. And with a flat universe, you can define a finite limit which you will not go past, whereas with an open it's slowing down more slowly, if you like, and there is no value you can set which you'll never get apart, whereas with the flat universe there is. So the description that works is a universe that will expand towards a finite limit, or if you prefer, the rate of expansion will tend towards zero. Tend towards zero is a slightly stronger statement than will get smaller, and means the same thing mathematically. Just as a side comment, I've put, of course, that for the open universe that means the density is less than the critical density, closed universe is greater than the critical density, and for the flat universe it's equal to the critical density. Suggest. Now this word suggest in a question always means that essentially you won't have been taught the answer. Suggest a reason why it's difficult to predict the future of the universe. Essentially this is either because we're not sure how much matter there is, or actually there's the more subtle point as well. So the existence of dark matter or holes or neutrinos means that we don't know the density that we've got. We've also got the issue that we don't know H0. So if we don't know H0 with great accuracy, then we can't measure the critical density with great accuracy, and therefore calculate the critical density with great accuracy, and therefore can't compare it to a measured density with any great accuracy. These things are about not knowing whether we can what happened there? What's not undoing? That's surprising. There we go. These things mean that we can't know how much matter is in the universe, so we're not very sure about the density of the universe. The final one in there is dark energy. Now, dark energy is just the idea that there is some energy because measurements suggest actually that the rate of expansion of the universe is increasing, which just completely rips apart the model and makes a bit of a farce about this whole part of the spec, frankly. So dark energy is another possible answer. So that was G485 homework booklet question 30, the end of that homework booklet. Thank you very much.